This is going to be section 11.2.2. We're going to take a look at system of equations with three variables. So today's objective, system of equations with three variables. Now to review the system of equations, first, solving a system of equations is finding where the graphs intersect. Now that's a little bit more difficult to visualize because now we're talking about a 3D graph. It's kind of weird. But maybe towards the end I'll be able to add in some, this is what it looks like in the 3D graph. Also, there are different types of methods in solving this. We've went over a substitution method, and we've went over an elimination method. We're going to use the elimination method to be able to solve a system of three variables. So here's our first example. System of three variables, how do we know? Has three equations. Now for us to do this, we said the elimination method, one of those key things about the elimination method is we want the coefficients to be opposites for the variable we're trying to eliminate. So I have to either eliminate the x's first, the y's first, or the z's first. Now me looking at this, it doesn't matter which variable that we eliminate, we just have to eliminate the same variable in both equations. So I'm going to pair one equation with the other two equation. And looks like I want to do equation 1 with equation 2 and one equation 3, and I'm going to eliminate the y's. So I'm going to rewrite them. So here's equation 1, here's equation 2, here's equation 1, and here's equation 3. And maybe I'll put numbers by it to help too. So I paired equation 1 with equation 2, and I paired equation 1 with equation 3. Now that's just easier for me to be able to go through and recognize how I paired it. Now I need to eliminate the same variable. So I said in the beginning, before I did anything, I want to eliminate the y's. So for me to eliminate the y's, I want the coefficients to be opposites. Well, this is a positive one, and this is a negative one. The coefficients are opposites, which means when I combine these equations together to create a new one, the y's disappear. So x plus x is 2x, negative y plus y is 0, z plus z is 2z, negative 1 plus 3 is 2. Y is eliminated. Now looking at this pairing, the negative y and the 2y, if I add those together, the y is not going to disappear. So I need to multiply by a number to make them opposites. So if this is positive 2y, I need this to be negative 2y. So I can multiply top and bottom by 2. So if I do that, I distribute 2, distribute 2, distribute 2, distribute 2. You get this new equation here. So now when I add those equations together to create a new equation, I get 6x, 3z, and 6. Y's are gone. So now the only variable I have is x and z. So now I want to do the same thing. I want to be able to go through this, and so I'm looking at these two equations together. So there's that equation, there's that equation. From here, I want to eliminate another variable. So it's basically two sets of elimination back to back. And so now here, I have to compare these. For me to eliminate, they have to be opposites. Well, to make these opposites, it would have to be 6. I'd have to multiply two equations by a number. For these to be opposites, it would still be 6, but I would only have to multiply the top equation by a number, and that's negative 3. So I'm going to multiply the top by negative 3, and so now if I distribute negative 6x minus 3z minus 6, now I compare these equations together, and so when I add them together to create a new equation, I get negative 3z equals 0. Divide both sides by negative 3, I get 3 equals 0, or z equals 0. So now I have one of the variables. But if I take this variable now and plug it back into the beginning, I still have two variables. I can't get one of them by itself. So I need to plug it back into an equation that I've already established that only has two variables. And I've established this equation here, and I've established this equation here. Now, it doesn't matter which equation you plug it into, but we're just going to go ahead and plug it into this equation here, which is also written right here. So if I plug in 0 in for z, you're going to get 6x plus 3 times 0 equals 6. Well, 3 times 0 is 0, so you're just left with 6x. Divide both sides by 6, you're going to get x equals positive 1. Then I need to take the z being 0 and x equaling 1, and I need to take those, and now I need to plug it back into the very original. And I'll just pick this equation. Why not? It doesn't matter which one. You can choose any of the three equations. And so plugging it back in, 4 times 1 plus 2y plus 0 equals 8. So then that becomes 4. Subtract 4 on both sides. Divides both sides by 2. You get y equals 2. Now, remember one of those things that I said, we're finding where they intersect. So where they intersect is going to represent a point. And so I need to write my answer as a point. 1, 2 for the y, and 0 for z. So what I did here is I paired one equation with the other two, paired one equation with the other two, and I eliminated the same variable in both. It will give you two equations. Then you need to compare those two equations to eliminate another variable. So I compared those two equations together, and I eliminated x. And that's how I was able to get z by itself, because after you eliminate, you only get one variable left, and I was able to get z by itself. Then you plug back in to a series of equations that's technically allowable. So I couldn't plug z equals 0 back into the original because I don't know what my x and y is. So I could only technically plug z into these two established equations, because then I can at least get x by itself. And it doesn't matter which equation you plug it into, you'll still get the same value for x. So I plugged it into this equation, got x equals 1. Then with both of those values, you can plug it back into the original equations, which I just chose this one because why not? Let's look at another example. So, same idea. I need to pair one equation with the other two. So I'm going to pair this equation with this equation and this equation with this equation. The variable that I want to eliminate is y. It looks like maybe z. So I thought y at first because this was negative 2y and positive 2y. But then I was like, that's a little difficult. Or not too difficult. But then the negative 2y with the 3y, well, I'd have to make them 6. So that's two different equations. Whereas comparing these, well, these will automatically eliminate already. And then 3z with z, I'd only have to multiply this equation by 3 to make them the same. So it looks like z's are going to be the way to go in terms of eliminating. So I'm going to pair equation 1 with equation 2. So here's equation 1, there's equation 2, and equation 1 with equation 3. Remember I said I want to eliminate the z's. So these are already opposites. So adding them together, y's end up canceling as well, which is great. It makes our life easier. So I get 5x equals 15. Now on this side, what I need to do is to make these opposites, right? I said I need to eliminate z. This needs to be negative 3z. So I multiply everything by 3. So that became 9x plus 9y minus 3z equals 12. Now that these are opposites, I can add them together to create a new equation. 10x 7y equals 23. Now normally you'd compare these together like so, and you'd have to eliminate another variable. But this is great I only have one variable for x, so I can get x by itself. Divide both sides by 5, I get x equals 3. And so now I can take that 3 and I could plug that in to my previous equation that I established. Now this is the reason why you had to do it for both, because if I had just stopped here, right, if I was like, oh man, look at that, x is 3, I still can't plug 3 into any of these because I don't know what y and z are. So that's why I still had to establish the other equation so I could at least plug my x into that equation. And so now simplifying that just to save time, that's 30 minus 30 on both sides, divide both sides by 7, y equals -1. Go ahead and pause there and take a look at that. But we're just getting a variable by itself, and we're pretty used to doing that. And so now I take the -1 and 3, plug those back in. I decided to do to the bottom equation again. And then so I plugged in 3 for x, -1 for y, get z by itself. We have it right there. And so to be done, you have to write an equation, or write the answer as a point, because it's where they intersect. So to conclude, what did we learn today? Well, we talked about a system of equations with 3 variables and how to solve them. This does conclude our lesson. If you have any other questions, please leave them in the comments.